All right, the recording has been started. And I'm going to go over these 3 questions. For those who are not joining this class today, please review these 3 questions to do the textbook practice problems. And of course, those who join today, you guys don't have to do it. It's an automatic 100. Example 1, sketch the curve given by the parametric equation x equal t squared minus 4, y equal t over 2. And the time, well, of course, time cannot be negative, but t is some parameter here. It's changing between -2 and 3. In order to sketch an accurate curve, so first of all, I need to know what will be the graph. So let me express y in terms of x or x in terms of y. I just need to know what graph am I trying to do. Okay, let me see. I think the easiest would be to express time from this equation. And if I'm too fast, please just stop me. You can also write me privately in the chat and I will slow down. From this equation, let me express t. T equals 2y. And I will plug it back into this equation. X equals, well, t squared 4y squared minus 4. And I am going to do x plus 4 to both sides. Plus 4 plus 4, x plus 4 equals 4y squared. Divide both sides by 4. Y squared equals x plus 4 over 4. Can anyone recognize this graph? What is the graph? This is, well, because it's a square, it's a parabola. It's a horizontal parabola, which is moved 4 units to the left, which means I can just graph it. 4 units to the left, 1, 2, 3, 4, and I will just sketch the graph. Well, maybe my parabola goes something like this. All right, can anyone please argue and explain why this graph is not complete? What is different in this case? Why I cannot just leave my graph as parabola? What other information am I missing? Can anyone tell me?
-2 and 3.
Well, from -2 and 3, it's, I mean, no, it's fine. I still have some points for t between -2 and 3. Oh, you're saying restrict the domain. Okay. All right, so this is one point. And the other point I need to know, because here's a parametric equation, the x coordinate is changing depending on time, and the y coordinate is also dependent on time. And unfortunately, on my graph, there is no time. So how can I also make sure that I reflect the time or location of any of my whatever point which is moving at a particular time? So this is a bit tricky and it takes a bit of more time. The best thing is table. T, X, and Y. And let me plug in all of the discrete numbers for t from -2, -1, 0, 1, 2, 3. So it takes a bit more time. And then just plug in these values into X and into Y. I'm sure you guys can do it yourself, so I'm going to do it very quickly. For X, I'm plugging -2. -2 squared is 4, 4 minus 4 is 0. I'm going to fill it up, and if I made a mistake, can you please let me know? Okay. And I will pause for a bit, and please tell me if I made a mistake there.
No, I don't think you made a mistake.
Thank you very much. All right, let me now graph these ordered pairs. Actually, my graph was not really accurate. Now I'm just graphing these ordered pairs. 0, -1, or it should be here. Let me just erase my parabola. I did not really graph it well. And I'm going to do another parabola very quickly. All right, 0, -1. That point happens at t equal -2. The next point is 3, -0.5. Wait, is it 3? -3. I made a mistake. -3, -0.5. Another point over here. That's at t equal -1. 0. All right, -4, 0. Happens at t equals 0. You guys following?
Yeah.
Okay.
Yeah.
All right. Stop me if it's too fast. It's a bit different, I would say. That's the longest problem. The rest of the problems, there will be 3 examples. The rest will be quicker. Okay. -3, 0.5. This point happens at t equal 1, 0, 1. Happens at t equal 2. And finally 5, 3. So maybe it's right here. Happens at t equals 3. So now this is a graph of parametric equations, and each point signifies the location of whatever is moving at the particular time. So this is the graph of parametric equation. And those who are not joining the class today, if you will draw me just the parabola from the textbook practice, I will take half of the points off because this will be just a graph. You need to identify the location at every point. So be please very, very careful with that. That's the difference between regular equation and parametric equation, because now we have another parameter, which is time. And I'm pausing here and asking you to ask me questions if something is unclear. All right, looks like everyone is good or shy. I don't know. Hopefully good. All right, 2 more examples. All right, next question. Identify the curve represented by equation. In this case, and also if you have this question in textbook, you don't need to draw it perfectly. You just need to identify the curve. What is that? Parabola, hyperbola, ellipse. You know so many other curves, so many curves already. In order to do so, I would recommend to express t from one of the equations and plug it into another. My suggestion, to express time from this by squaring both sides. X squared equal 1, and radical squared will be just t plus 1. And I can then do t plus 1 equal 1 over x squared and subtract 1. T equal 1 over x squared minus 1. And this beautiful stuff is going into y. I'm going to pause for 10 seconds to give you a chance to catch up, or maybe go ahead and try to plug it in on your own. All right, plug it in. Y equal t. I'm plugging this 1 over x squared minus 1 over 1 over x squared minus 1 plus 1 goes away. And I will just rewrite it as 1 over x squared minus 1 divide by 1 over x squared, which really means multiply by x squared. 1 over x squared minus 1, whole thing. Well, you change division to multiplication, flip the fraction, multiply by x squared, and it's 1 minus x squared. So what we have? Y is 1 minus x squared. And who is that? Who can tell me? What is the name? What's the curve? Anyone? The curve is very familiar to you. I'm sure you all know, you're just very, very shy because it's parabola. That's our standard parabola, y equal 1 minus x squared, which is vertical parabola, opens downwards because of negative in front of x squared. I'm sure you guys all know this. I'm going to pause for 10 seconds, making sure you all have enough time to take the notes. And this question will be on the test for both seniors, for everyone, so juniors, seniors, sophomores. I already created your final exam. This question is on the test. You have to express t from one of the equations, plug it in the other.
Wait, so there's two answers?
No, there is one answer. What I did here, I expressed t first, and then I plugged it in into my other equation. It's just one answer. It's a relationship between y and x.
Okay.
And once you get this, you already know that y equal 1 minus x squared. That's parabola.
All right.
Wait, miss, do you have to find, after you find t, you have to find y, or is it depends on the equation?
So what I did from this equation from x, I expressed t. And then this t I plugged in into y. Because I want the relationship between x and y, in order to identify the curve, I need to know the relationship between x and y. And once I plugged in this t, which is now in terms of x, I plugged it into y and simplified. I will have relationship between x and y, and that's it. And now you know the answer.
Oh, okay.
Anything else, guys? Any questions for this particular slide? All right, one more then. Just one more. Last one. Sketch the curve represented by x equals 3 cosine theta and y equal 4 sine theta, while theta is changing within one rotation, 0 and 2 pi. It's one whole rotation. It looks pretty scary. However, the solution is not that bad. I know Pythagorean trigonometric identity, sine squared plus cosine squared theta equal 1. Well, I need to express cosine and sine. Let me express cosine from here. I know that cosine, not squared, just cosine. Then cosine theta is divide both sides by 3, x over 3. And from the other one, sine theta is y over 4. And again, I'm pausing for a bit to give you an opportunity to write this down. And maybe you can already go ahead and square cosine and sine and see what happens. Okay, then since in the equation it's sine squared plus cosine squared, let me square them.
X squared over 9
Yep.
plus y over 16 equals 1.
Correct. Thank you. X squared over 9 plus y squared over 16 equals 1. Who is that? Oh, my pen is acting out. Let me erase that.
An ellipse?
Ellipse, correct. That's a beautiful ellipse. It's a vertical ellipse because this number is bigger. So it looks something like this. This distance is 4, and this distance is 3. And again, this question will be on the test. You would have to simplify it and identify what is that. Ellipse. Yeah, I think that's all you would have to do. That's all. I'm going to stop recording and I will then answer your questions. All right,